All right, we're going to do 10.6, and this is actually also going to include 10.7 as well. So we're getting into our circles unit. So let's define a circle. It is a set of points which are equidistant from the same point, which is called the center. And a circle is also going to be named with its center. Okay, so basically a circle, you have a center, and then every point around it is the same distance away from that center. Now we've got these parts of a circle that we need to identify. So first we have a segment with endpoints on the circle, and it can be anywhere on the circle, and that is a chord. If you want to draw a little picture over here, a chord can be anywhere on the circle, so it can just go from here to here. Could be a chord. Now an angle with its vertex at the center of the circle is called a central angle. And all of those that are in a circle add up to 360 total degrees. Okay, so if you have a circle, then right here, we'll call it X, could be a central angle, because I'm talking about this angle right here. So all the way around a circle we know is 360 total degrees though. Then we have a segment with one endpoint at the center of the circle and the other on the circle, and that would be a radius, which we have heard before. But a radius specifically has to go from the center to the outside. Okay, so if it goes from the center to the outside, it's a radius. So then a segment with endpoints on the circle but must go through the center is a diameter. So if we have a circle here and we have our center, a diameter must go from end to end and go through the center. So those are our parts of a circle, so let's go ahead and identify some on this circle. This is called circle. Oh, never mind. That is our first question. Name the circle. This is called circle D because D is the center of the circle. B says to name a chord. A chord can just go from end to end of a circle, so we can use EG as a chord. EF could also be a chord because it goes from one part of the circle to the other, one part of the circle to the other. Okay? Now name a diameter. A diameter has to go from end to end like EG, but it has to go through the center, so it has to be EF. So EF is a chord, but it's more specifically a diameter. And then a radius then should go from the center, so we have to start at D and either go to F, or at D we can go from D to E. So I can name that ED or DE, or I have DF or FD. The order does not matter as long as it is a line that goes from a center to the outside. All right, so let's find radius and diameter. If you remember from your previous experience with circles, a radius equals half of a diameter. Okay, so a radius, they're all going to be the same around a circle because this center is equidistant to all of the points around the circle. So if a diameter has to go through the center, then it's going to be two radiuses. So you could also say one diameter equals two radiuses, either way. So then we have to look at these and see what we were given. So in A, I have DF, so this whole line here is 10, and I want to find DA, okay? So DF is a diameter, and I am finding a radius, so DA is going to be 5 because we have to take half of it. Now, let's look at choice B. In B, we are given PA right here is a radius. So let's find PG. Well, PG goes across the whole thing and through the center, which makes it a diameter. So we have to double PA, because I would have 7 here and 7 here, which makes 14. All right, now the last one, let's see what we're given. So if I give you that AG is 12, that is a radius, and we need to find LA, that is also a radius, so LA is 12, because any radius in the same circle is the same. All radiuses are the same, all diameters will be the same length given the shape. Let's flip the page over. All right, now we are going to talk about arcs. So an arc is a part of a circle, and a semicircle is a type of arc that is half of a circle. So a couple more vocab words. There will be a lot of vocab words in this section. So we have two kinds of arcs. We have a minor arc that is smaller than a semicircle, and then a major arc is larger than a semicircle. So looking at this picture, RS right here, this red section, is a minor arc because it is less than half of the circle. So if I just draw a line through this circle, then we'd be talking about this would be a semicircle, okay? So RS is smaller than it, so it's a minor arc, whereas this S from S through T all the way to R, all of this is a major arc because it is actually bigger than half the circle. So let's go ahead and name some arcs in this picture. So we can name some minor arcs for circle O. We know it's circle O because that's the center. So a minor arc could be from A to D, smaller than half of the circle. Even from A to C is still going to be less than half of the circle. And these are arcs, so instead of a straight line above, we actually do a curve. So AC would also be a minor arc. And you know, so then we're looking at semicircles. You know something is a semicircle if it connects, let me do this with a different color, if it connects two ends of a diameter, because a diameter is cutting this right in half since it goes through the center. So DC could be a semicircle. You could have CD going the other way too. Either way, they're both semicircles. So another one you could have, another semicircle you could have could be going from A to E or from E to A. So those would be two different semicircles you have. And then let's talk about the major arcs. Major arcs, just make sure you're going over halfway. So if I start at D, I need to go halfway and then a little bit more. So this would be a major arc. And with a major arc, we can't just call that DE because then you should probably go the shortest way to that, which you wouldn't do. You need to go the longest way to make it a major arc. So we can call this DAE. You could have called it DCE as well. As long as you go from here, you show a point that you went through and then to your other end point. That can be a major arc. I'll give you one more example. We could start at C and we need to go past the middle and we could go all the way to A. So I could call this CDA or I could have called it CEA. Either way will work. All right, so just so that you know how to name some arcs, now we're going to go into arc measure. So the measure of a minor arc is equal to the measure of its corresponding central angle. The measure of a major arc then, so that was minor arcs, the measure of a major arc is the measure of the related minor arc subtracted from 360 degrees. And that will make more sense when we do an example below. then the measure of a semicircle must be 180 degrees. Because if you think of a semicircle, it has to go from one end of a diameter to the other. Well, we are on a straight line here, which we know is 180 degrees. So the arc must be 180 degrees. All right, so let's look at this example about the measures of arcs. So if I want to find the measure of arc RT right here, it is equal to its central angle that it correlates with. So I look at those radiuses that it used to trap that in. So the measure of RT would be 50 degrees. We're talking about arc measure, so we're still going to talk in degrees. But now the measure of TQR, so I go to T, and I need to go through Q before I can get to R. So I know I'm talking about this major arc. Now, it would be equal to this whole angle that is left over. So that's why you can do a total circle is 360 minus the 50 you know about to get 310 degrees. So if this whole blue angle is 310 degrees, it means this blue arc TQR is 310 degrees as well. Okay, so a circle has 360 degrees. We know that already. All right, then we have the arc addition postulate, which is very similar to the segment addition or angle addition postulate that we know. Just part plus part is whole. So the measure of the arc formed by two minor arcs is the sum of the measures of the two arcs, okay? Part plus part equals whole. That's all this is, okay? So it took the measure of AB right here, and it added on the measure of BC right here to tell us that the whole thing, if we added those together, we would get the measure of arc ABC. Pretty simple. All right, let's go on to circumference. We already know circumference. We've actually already done that a little bit, so let's review that. Circumference measures the distance around the circle. So this is on your formula sheet, but circumference is represented by a capital C, and there's two different ways we can represent circumference. We have C equals 2 pi r, which is probably the one you know the best. But we know that two radiuses make a diameter, so we can also say that circumference is pi times diameter, since diameter is two radiuses. All right, so we can use either one of those formulas depending on what information we're given. So let's use those in these examples. We're going to either be finding circumference, diameter, or radius depending on the question. So question A says to find circumference if the radius is 7 centimeters. So if I'm given a radius, I should use 2 pi r because that one uses a radius. So my circumference is going to be 2 times pi times my radius. Now if you are leaving that in terms of pi, you should just multiply the numbers. So 2 times 7 is 14 pi. So we can leave our answer as 14 pi, or we can keep going and actually multiply this out in our calculator, and we can call this 43.98 if we're rounding to the hundredths place. Both are correct answers. This is an estimate though, because we rounded. So if they want exact, you should keep it in terms of pi. So this is rounded, okay? Now in B, it says find the circumference if the diameter is 12.5. Well, the circumference formula that uses diameter is pi times diameter, so I should use that one in this case instead of trying to find my radius. It's not necessary. So circumference equals 12.5 pi. I didn't actually have to do any math here to get it my exact answer. So here is my exact. But if it wants a rounded answer, it tells you to round to a certain place, then you can do that and call this 39.27 as well. Last one, we're going to find the diameter and radius to the nearest hundredth if circumference is 136.9. So you can do this one of two ways. Use either formula. So if I want to use circumference equals pi times diameter, I'm going to fill in what I know to get my diameter. I know my circumference is 136.9. Pi is a number, not a variable, so that's okay. And then I'm still going to be solving for diameter. So to get diameter by itself, I'm going to divide by pi. And I will get that my diameter is 43.58. All right, now 2 different ways then you could get your radius. You could just do your diameter divided by 2 because radius is half of that. So we could do 43.58 divided by 2 and we would get 21.79. So this is your radius. You could have also actually used 2 pi r and filled in 136.9 equals 2 times pi times your radius divided by 2 pi, and you would have gotten a similar answer for your radius. So either way you want to do it, as long as you are solving for your missing piece. All right, let's find the exact circumference of this circle. This is another one you can get, and they like this kind of question because it involves another part of geometry, which is your Pythagorean theorem. Because we have a right triangle here, and if I am finding circumference, I either need a radius or a diameter, which I do not have right now because those have to go through the center or from the center. So I can do 5 squared plus 12 squared equals c squared though, and solve and get that c is 13. That means this whole side is 13, so my diameter is 13. I should use this formula. So, and it wants an exact answer, so I will just call this 13 pi for my circumference. All right? 40.84 would be the estimate for that, but it wants exact. Let's go on to the last section here. This is more of our 10.7 stuff where we have arc length and area of a sector. This is the last stuff we've got. So arc length, this formula is something that you have to memorize. The measure, so we've done arc measures, which are in degrees, but this is arc length. So this could be in inches, this could be in centimeters, something like that. So to find the length of arc AB, I have to look at the ratio of the arc measure to 360 degrees and then multiply that. If you notice, these 2 formulas are both your circumference. So a lot of times we'll just talk about the measure of the arc over 360 times circumference is your formula. Let's try an example. What is the length of each arc shown in red? It won't be red on your page, but you can see it on here. So I am finding this arc. So I find the measure of that arc is 90 degrees because its central angle was 90. So I do 90 over 360 because I only want that portion of my whole circle, and the whole circle is 360, times my circumference. And I was given that this whole thing is 16, so that's a diameter. So let's go ahead and use pi times diameter. It says leave your answer in terms of pi. So I will just do only the math parts of this, the number parts of this, I should say. 90 divided by 360 is 1/4. And then 1/4 of 16 is going to be 4. So I can call this 4 pi. All right, let's do the next problem. So I am finding this whole arc right here, the length of this. So the measure of it, it says it is 240 degrees. So 240 divided by 360. Now I'm given a radius in this case is 15. So I should use 2 pi r instead for my circumference. When you go ahead and do this math, ignoring this pi, you actually get 20 pi. Because 240 over 360 simplifies to 2/3 times 30 is going to be 20. And then we tack that pi back on, so that would be our arc length. We also have area of a circle, which is a review. Area of a circle is on your formula sheet, but it is pi r squared. So you have to use a radius for area of a circle. You cannot use a diameter like you have the option of with circumference. So let's do one problem with the area of a circle. It says, what is the area of the circular region on the wrestling mat if the diameter is 32? Well, giving us a diameter is still helpful, but I need a radius. So I need to do diameter divided by 2 is 16 is my radius then. So then I can use area equals pi r squared. So pi times 16 squared. Now, if you want to leave this in terms of pi, then you can call this 256 pi. If it wants an exact answer, it didn't specify here, so let's go ahead and give both. Or go ahead and do 256 times pi, which is 804.2. And this would be feet squared because we're talking about area. So those are two acceptable answers for this problem. The last thing we have is sectors. And because we will be finding area of a sector. A sector is a region bounded by an arc of the circle and two radii to the arc's endpoints. So naming a sector, you can use one arc's endpoints, the center of the circle, and the other arc's endpoint. So all of this that is shaded in yellow right here, that I'm going to shade in red, is a sector. It's like a piece of pie. That's how I like to think of it. And then they call this RPS. It goes from an endpoint to the center and then back to the other endpoint so that it traces out this slice of pie there. Okay? So reason why we're talking about this is because we've got one more formula that we'll have to memorize, and that is area of a sector formula, which is this right here. It is still the measure of the arc over 360 times pi r squared, which is our area. So a lot of times we just say measure of the arc over 360 times area. So then it's not as much to memorize because you know your circumference and area are on your formula sheets. So let's do one last example and then we'll be done. Finding the area of a sector of a circle. What is the area of sector GPH? Okay, so we're going to leave our answers in terms of pi as well. So I need to do the measure of the arc. The arc, it tells us, is 72 degrees. So 72 out of 360 total degrees. And now, because I'm doing a portion of this circle's area, that's why this covers a portion of it, and timesing it by area of this whole circle. So pi r squared, it actually gave me a radius in this case, so I can use 15 squared. Now, if we are leaving this in terms of pi, this ends up going to about 0.2 times pi times 15 squared is 225, which ends up being 45 pi for my area of a sector. I know this is a lot of stuff to memorize. You learned a lot of new things about circles, but we'll go ahead and talk about it a lot more in class and do some more practice. Make sure this is fully filled out. See you in class.